Okay, and welcome back, everybody. I am glad you're here, and I do uh, want to mention that it's okay with me. I would be happy if you want to subscribe to my YouTube channel. I try on these heavy lift drone videos to put them up to my YouTube channel, and I put in the description my website and some discussion of what the video is about and some of the previous videos. I don't want to make them too long, so I make a short one and then send it to YouTube and then make another one. So this one is number 4. And we are working through the concept of a heavy lift drone for a military application and just discussing what would be the issues involved. The question of whether there could be a standardized control system, and how would it happen if the military decided to hand these heavy lift drones to their people. It is a discussion, so we try to start out with this. We just want to be sure to remind you that we are making a discussion. If you want, I think that this drone could be physically created, but you need to understand any physically real object could possibly hurt somebody or cause damage. We advise, do not make any physically real object if you cannot manage it in a manner that is legally allowed and reasonable and safe. So we always try to start with that. There are multiple drones that we're talking about. This is the drone based on the de Havilland DHC-2. This is the largest drone. It does have the ability to take off going straight up, and then it can fly as an airplane and then put itself into a significant stall and then land going straight down. These are tilt rotors. The military, our thinking was the military created a combat aviation group, which is the people who would have this drone capability at a isolated forward outpost or base. In the military phrases, they have the concept of a forward operating base. The thought is to have 3 of these drones sent to the forward operating base, and they would just be there at the base under the control of the commander of the base. And if his people or her people were out deployed away from the base and some sort of trouble occurred, these drones could just simply take off, go to the area where the problem is, and help. Which would be different from the current situation where someone at the base has to call the central command and find out what kind of air support is available and ask for it, and then everybody waits for the air support to show up. So this is a different system. And they took, in our story, this is Sergeant Charles Miller, whose nickname is Charlie, good old Charlie. They made him as a pilot and put him in charge of his group of 5 people, a medical or mission officer or a mission person, Sergeant Carolyn Monroe, and 3 ground support troops. And Charlie is working along to create this combat aviation group out of nothing. What has been a surprise to Charlie is that he spends all of his time, it seems to him anyway, he spends a lot of his time working on making this a functional aviation activity. And what he has discovered is that an aviation activity has a ground-based component and an air-based component. The air-based component is what flies around. He thought, being the pilot, particularly since it's new, that he would be up in the flying device, flying around, almost basically sightseeing, having a good time and just relaxing while he flew around in the airplane. And what he is discovering when you create an aviation capability out of nothing, the ground component is fundamentally important. And in the absence of a proper and functioning ground component, you're not going to have a safe or reliable or effective air component, the part that flies around. And Charlie is working through everything associated with creating an aviation ground component out of nothing. There are the other bases. They too received their drones, and Charlie and his mission support person, they try to, if they can, have a video conference every 2 or 3 weeks with the other bases, their pilots and mission persons, to go through problems they're running into and solutions that they're finding, solutions that seem like a good idea and turn out to be a bad idea, and solutions that actually work, so that they don't have a requirement to reinvent the wheel. Charlie did have a concern. He was worried. He didn't think that the drone should just be sitting on the ground, protected by nothing. These drones could bring supplies to the men who are women who are in a battle. They could bring reinforcements, or not a lot of people, but they could bring people. They could bring ammunition. They also could pick up and extract away and take out for advanced or higher level medical care people who had been wounded. And there is a possibility that they're going to put weapons on these drones. All of this meant that from an enemy viewpoint, they are going to comprehend quickly that these drones are important and can change the battle, and probably will. And what needs to be done is to make the drones go away or not function before any battles really get going. And, you know, if the drone is just sitting on the ground, they could try to hit it with a mortar or a rocket-propelled grenade, or they can't really get that close to it. They can get the 50 caliber sniper type bolt-action long-distance rifles and put bullets through the engine and render the drones unusable, or a rocket-propelled grenade or mortar. So Charlie wanted to get these drones where they existed in a protected fashion, and that's a building or a hangar. You can make a hangar that keeps the sun off of the plane. You can make a hangar that keeps the rain and the sun off of the plane. You can make a hangar that hides the plane. When you start to make a hangar that protects it from weapons, you get into the explosion proof or hardened or impact resistant bomb proof construction of a building. And the truth of that is, the bigger the bomb you make the building that it can withstand, the more complex, heavy duty, and expensive the building becomes. And so you have to make a decision about just how much protection do you want to have for this flying machine, and how are you going to do that? And these were the issues that Charlie was thinking about. One of the things that's important to notice about airplanes is airplanes have a lot of distance because of their wings, and in the right angle to that, they have a lot of distance because of their tail. And so airplanes as a structure become items that it's difficult to create a building that they can get into, because you need the roof needs to have the vertical supports for the roof need to be, this is 38 or 40 feet here for this DHC2. So you can't have any vertical supports any closer together than every 38 or 40 feet. And what happens is if you want to put sand on top of the roof or dirt, sand is very heavy. And it's a roof load. It's a roof loading problem. And you can't just make any roof to do this. You have to have a roof that can withstand that kind of weight. And so what we want to work or talk about at this point is how are we going to make a hangar for this drone that protects it from being hit by small arms fire and small explosive munitions, not 500-pound bombs, but at least perhaps small arms fire and small mortars and rocket-propelled grenades. And the question is, well, what does the military do to do that anyway? And many things, but one of the things they use is the HESCO walls. And so we're going to go and look at that on the internet. I thought this would be an easy discussion, that I would just type in there size of forward operating base and get the answer. But it's just not that way. It's very strange. Here is a forward operating, each of the forward operating bases are given a name. This is forward operating base Logar in Afghanistan. And here is the guard towers and where the people are, and then the wall that goes around it to protect it. And you'll notice they tend to try to build it out where it's away from everything, and it is protected by the HESCO bastions, and this is a image of them, and they are a polyester fabric material with wire mesh to help it keep its shape, and they fill it up with sand. And apparently in the quote, in the old days, the soldiers would fill up sandbags. Now they use these barriers, and the barriers are filled up. You can see this has been protected by a bucket loader that picks the sand up and just dumps it into these HESCO containers. And so that tends to be the protective blast-resistant wall that is used by the military for their forward operating bases. And here we have another image of the wall created by this sand. Here's the sandbags. This is what they do for the more detailed work. But here is the bucket loader that fills this with sand, which makes it very easy to create a protective wall. And so if we go back to this HESCO bastion, the question that can be a question is, you know, this could easily stop. This weighs, I bet this weighs 12,000 pounds. So it would stop munitions. But here it is put together, protecting toilets. But the question is, could this be the wall of a structure? So if you were going to make a hangar for a plane, could this be the wall of a structure? And this is a German, it says in the credits, a German Camp Marmol. And here are it's a double, looks like a double thickness of these HESCO barriers. Here they have the HESCO barriers around the structures, but the HESCO barriers are not really acting to support anything. They're just there to, you know, if a mortar landed right here, it would wipe out this tent, but the hope would be that it would not wipe out that tent. It would wipe out this one and this one, but it wouldn't wipe out that one. So that's what they're doing. And the other thing we can look at, this is looks like they're discussing the military, the people who supply the HESCO barriers and what they are and how they work. And here's the HESCO barriers sort of protecting aviation equipment, but again, they're being used in the manner of being just a wall of protection, not really as a structural wall. So that was a question that people were curious about. So they asked the Army from a civil engineering viewpoint and from a architectural viewpoint. I think this is the name of the report. Can these things be used, this HESCO stuff, as a structural item? So here you can see they're putting weight on it this way, and they pushed it back and forth that way to see if it would turn over. And this is 2017, so it's not that old. One thing they put in here, which is a little surprising, but only that I didn't know this. This shows how it's manufactured and what it looks like, and this is resistance for being toppled over or pushed apart by a shear force. Density of sand, 1.38 grams per centimeter cubed. Here is the building that they were going to look at with the HESCO walls and the beds in there that the people were going to sleep in. And you'll notice they had another wall here that was separated from that wall so they could go in and out. But mortars that landed, a mortar that landed here would not get inside the building, and a mortar that landed here would not get inside of the building. And it looks like they wanted to build wooden trusses with vertical support columns and sandbags on top. And I think they were coming to 206 pounds per square foot of total weight. And the sandbags were 24 inches deep. So at least you can use the HESCO wall as let me rephrase it. You can use the HESCO structure as the wall to hold up a building. That was what needed to be looked at. And this is 80 pages. All right, so it looks like you can. And we can go back to our airplane that we're trying to protect, and it is, the wings are 47 feet long, the distance, the wingspan of the plane, and the plane is 30 feet long, and in terms of a vertical distance, it's about 12 or 13 feet. So if we wanted to have a roof over this, the roof is going to need to be at least 40 feet by 32 feet. So we can go down here and make a little box. 44, 34. So that's 44 by 34 feet. And then let's just put 1 foot of sand in there. That's our roof over on top of this plane to protect it. And so we can bring it up here and show that this at least is a roof that could be over top of this plane for a hangar that is protecting the plane. And the reason that I'm doing this is to show you it gets out of control fairly quickly because of the weight of the sand. Okay, so we have our little roof that's on top of this plane, and that roof is and this is a 1 foot thick layer of sand. It's 42 million cubic centimeters. So we can take 42 Okay, that's 58,459 grams of sand. And then we can pull up our conversion program, volume and mass, and convert grams to pounds. So 1,000 grams, 2.2 pounds. So that works. So 58,459,562. So that roof made of sand over this plane would weigh 128,000 pounds. And this is where everything gets really complicated, because what are you going to do to hold up 128,000 pounds? But you can't put a vertical post in here, because if you put a vertical post in here, then you can't get the plane under the roof. So we can think about that. There's another issue, and that is that people have all-terrain vehicles in America, and they put them on their country land, and so frequently that land has a trail on it for the all-terrain vehicles, but invariably there's a valley or a ravine or a creek or a river or something that they need to get across. And a lot of people create all-terrain vehicle bridges. And that's what we're going to talk about next. And of course, if you type in roof trusses, that gets complicated very quickly. That's what we're looking at, is a truss for the roof. But you can type in pedestrian bridges or all-terrain vehicle bridges. The interesting thing about all-terrain vehicle bridges is that they're wider and they're stronger, because if it's 20 or 30 feet long or 40 feet long, it's only a matter of time before someone's going to they're going to drive out there with 2 or 3 all-terrain vehicles, and all 3 of them are going to drive on the bridge at the same time. And each of the all-terrain vehicles is probably going to have 2 or 3 passengers, and those passengers weigh 200 pounds each. So now you're putting, 1,400 pound vehicle and 600 pounds of people. That's 2,000 pounds per vehicle, and 3 vehicles on the bridge. So you have it holding up 6,000 pounds. And in addition, a lot of this is up north where it snows, and the snow falls down and lands on the bridge. And so the bridge also has to be able to withstand or hold up a snow load. So we can look at, again, you can go to Google and type all-terrain vehicle bridges. And I thought this was kind of interesting. Rollingbarge.com. I don't know where that name came from. They're up north, Canada. But here they have 3 all-terrain vehicles and a wagon, and it's going across a valley. And here's one going. This is so they make them 6 feet wide for all-terrain vehicles, and they make them 4 feet wide for pedestrian bridges. And they pride themselves that it all comes as a kit that you can put no part over 8 feet long, and it comes in a pallet where you can put it on your all-terrain vehicle and take it out to wherever you're putting it together. And you can see it's aluminum. This is a pretty long piece of it, and these three guys are holding it up. That's how it looks. And the way that it's created is you make these segments, and then you connect the segments together. So the length of the bridge is equal to how many of these segments you want to put together. And then again, this is Rolling Barge doing some work for Michigan, state of Michigan, a footbridge, pedestrian bridge. And they're putting it together on the ground. And here is 4 segments put together. And they lifted it up, most likely with this excavator, and they put it across the bridge. And here we have the same thing going across a creek on some person's property. It was an all-terrain vehicle bridge, same company, Rolling Barge. I'm sure there's plenty of companies that make these. Here's how it arrives. Here is 1, 2, okay, here is 1, 2, 3, 4 of these segments. They've been constructed and they're just sitting on the ground. And he put some scaffolding out in the river, and then it looks like they walked the section out there, and they would bolt the sections together across the river, and they put, they made a 56-foot all-terrain vehicle bridge. That doesn't look complicated. And based on the principle of how this bridge withstands the vertical stress on it, you'll see the bridge does constitute a structure that holds weight with no vertical supports under it, which is what we need. The bridge is not going to have all-terrain vehicles on it. It's going to have sand on it. And I think with this form of truss-based construction, a bridge has the floor on the bottom and the walls of the bridge on the side, but you can turn the whole entire bridge upside down so that the floor of the bridge is up on the top and the walls point down. And at this point, the bridge really is not a bridge anymore. You can use it as a truss for a roof. And I thought, well, okay, let's see if we can. And of course, that would have to be proven by civil engineers. I think they're going to establish that that's a completely acceptable thing that you can do. You might not be able to do that with a suspension bridge, but you can do it with a truss-based square cross-section X angle bracing truss bridge. I think you can just turn it over, and instead of it being a bridge, you can use it as a roof truss. And I thought, okay, let's see if we can protect these planes. I thought I would, HESCO, it looks like this is the trade name of a company that makes them, and it winds up that these are basically called HESCO barriers. It doesn't matter where you bought it from. The military thinks of them as HESCO barriers, and 1, 2, 3, 4, this is getting pretty tall. I'm not sure what this is, but it's military construction. But what I wanted you to see was the HESCO containers come in a variety of sizes, and they have a name, military 10842, 108 inches tall, 108 inches tall, 42 inches wide, and it looks like 10 feet 5 inches long. So, or whatever you want. But anyway, I wanted you to see that size because I thought I would get into SketchUp and create a very real looking version of this HESCO container with the little bars and the fabric material, and I got it filled with sand. That's kind of pretty. But this is a complex structure for SketchUp. And what happens when you make a drawing in SketchUp that has 40 or 50 or 80 of these, it gets to be so big that SketchUp can't draw it anymore. So I had to do a kind of a fake-o where it's just I wanted to show how this loops over, but that makes it complicated again. So I finally wound up just making this with just a texture. So this is my version of the HESCO container, and let's see what size we got here. So that's 42 inches, and that is 10 feet 5 inches, and that's 108 inches. So this structure of a HESCO structure that I created in SketchUp is one of the HESCO bags that you can get, and you can put them on top of each other as long as you keep the base of it wider than the next layer up. And so now it becomes, well, how are we going to protect this plane? And I have here that I created for you. This is, and you'll see what this is all about. This is a mortar going off. And so I drew in, here is the mortar going off right here, and here is the effect of the mortar, so that you can show, if you're going to build a protective structure for your planes, go ahead and drop a mortar over there and see. Now the mortar does not send out shrapnel that goes around a corner. The mortar sends out shrapnel that goes straight out. So you can draw this type of a structure to show the shrapnel pattern of the mortar. And then I took these, I have another conversation about a tractor. I think that another issue that the group is going to find is these drones, the DHC-2 has modified by Viking and can weigh up to 6,000 pounds, and they're not going to be able to move that around by just pushing it. They're going to have a tractor. It's a separate video. But I went out and carefully looked at the way that those rolling barge ATV bridges were made and put one together. And the important thing to remember, and there's a lot of ways to do this, you can so all you've done at this point is taken this bridge and flipped it over. And it's my opinion, from a geometric, mechanical engineering, civil engineering concept, this is just as strong for holding up a weight right side up as it is upside down, because of the way that these X trusses are put together. And you'll see why. But the other thing I did that I thought was important was to take these walls, and this is the correct word, yeah. Take these walls of the truss and narrow it down. So it's only, it's a foot wide down here, and it's almost 6 feet down there. And let's see. And it's 71 feet long. And that, if you go to the Rolling Barge website, their dimensions are 72 feet. That's the longest one they make. And so I went over and said, how are we going to do this? And remember, you can make the concept of a little square space like this, and you put the plane in there, and then you put a door across here. But that door is going to be 47 feet long, a foot thick, and 13 feet tall, and that door is going to weigh 128,000 pounds, which is like 60 tons. And you're going to have to roll that door. And if that door ever turns over, whatever's under it is gone. The drone is gone. Any people under it are gone. And if a bomb goes off and hits the door and makes the door so it won't work, you wind up with your drone protected inside of your protected area, but you can't get the drone out of there. And so I wanted to make the hypothesis that you're better off to make a facility where this door is open and just make these ATV bridges and start seeing, is it really feasible to make a structure where there is no door? You just roll the drone in there, and you have to keep rolling it backwards. And here I put the mortar in here blowing up, and you'll see that the mortar, you can't store the drone here or here or here, but at some point the explosion of the mortar doesn't get up into here. And so this whole entire area up here becomes a place where you can store your drone, and if they drop a mortar on it, it's not going to blow it up. It's not going to hurt it. And you can see that these, and that is the reason why I made the roof truss to be narrow here and wide there, because it lets you swing it around the corner. And you might say, let's just, we'll do something real quick here. All right. So you might say, well, this just looks sloppy. We don't like that. Let's do this one. Nice and clean. Here's your HESCO wall. Here's your little bay that you back the plane into. Here's the bomb, so the wall goes out to here. So the mortar, this is a roof here, so the mortar can't land anywhere. The mortar has to land outside of this space. So these shrapnel rays from the mortar are going to hit this wall. So this shrapnel ray makes it in there. So if you make this long enough that you can back up the plane, then if the mortar lands here, it can't hit the plane. And you're like, well, that is great. And you just take these and stack them on there. You just keep putting them on there. And now, right now, I think you can see I have this configured as a bridge. So it's not really a roof truss, but you know, that's not hard to change. So now it's a roof truss. And you just start stacking them up. And you would put them up there like that, and then you would put, you know, you'd get the bucket loader. You can make these on the ground, and then you can pick them up with the bucket loader and put them up on the wall, and then you can take the bucket loader and put dirt up here. And everything is cool, and it's really neat, except for one little problem, which is when you finally get up to here, okay, this space up under this roof truss has to be open so that the plane can go in there, which means that the question becomes, when you start taking these that are going this way, they don't have any problem at all was sitting on the HESCO wall. But what are these going to be sitting on over here? What are you going to put them on? Because if you bring them over here and put them on top of this truss, when you put a foot of sand on top of it, is pretty much holding up about as much weight as it can hold. So you can't take 128,000 pounds of sand, or half of that would be 70,000 pounds of sand, and put it on top of this truss, because this truss is not strong enough to do that. Now, it could be you go to the military and say, I want a whole bunch of these little trusses, and then I want, the truss of God that goes across here, because this truss has to be strong enough to hold up all of these. And by the way, this little corner of your HESCO wall, not only is it holding up this truss and some of this sand, but now this corner of your HESCO wall is holding up 1, 2, 3, 4, 5, 6. It's holding up 128,000 pounds on this corner. And so because of that, from a design viewpoint, I just said, okay, I'm not doing that. And what you do is you make these pie-shaped roof trusses, and you bring them up here, let's see, to this corner here, for example, right here, and you start swinging them around. And as you swing them around, you go from this axis to this axis, but you never have a truss that's holding up all the other trusses. And that's why I did it that way. And I don't know what to say. I think these drones are going to cost $8 or $9 million each. They're going to save the soldiers. They're going to turn the tide of the battle so that the American soldiers win instead of losing. They're going to deliver ammunition and supplies. They're going to take back soldiers who are injured. They're going to be immediately available. If the battle is 4 or 5 miles away from the forward operating base, these planes will get there in 4 or 5 minutes. And if they ever get weapons on them, they can fly up in the air and shoot at the enemy. So I think the soldiers are going to say, yeah, let's have this. And if you've got a 23 times that $24 million investment, how much are these trusses going to cost? I don't think they're that expensive. And they show them in the videos from that. It has such a strange name, holo barge. Just 2 or 3 guys and a ratchet wrench, and they just ratchet it together and put the bolts together. So, this might take 4 or 5 guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 30 of these. It might take them 15 days, but so what? Who cares? And it's a door that's open. There's no door down here that can fail. If the mortar goes off right here, it's not going to wreck the door. And you can put a HESCO wall here. Now, I spaced them apart a little bit in here so that the people who are inside, and I think this is a cool view, the people who are inside this thing, okay, so there's the planes. I mean, to me, that's just cool. And I, you're only going to have 3 planes, but I put them in there to show that they will make it around the corner. Okay, but I thought that the guys or the girls or the ladies or the people in there need to have a way where if they had to get out of that thing, they could run through this doorway here and go around this corner and run out of there. So that was an exit for them to get out of there if they needed to. So they're not trapped in this hangar. So they could run through here. And that's another door here. And I made this door a little bit wider so that you can back one of the drones in there. And I haven't quite finished it yet, but you can back a drone in there. And so that means that this drone, if this one wasn't the one you wanted to use, but this one was, then you could back this one in here and run this one out. and I put in the mortar explosion to show that there it is. So all of this space up here is free space. You can put your 3 drones back up in there. And I put this cover of trusses across here because this is that doorway with the right angle to it. So that means if the mortar can't land here, the mortar can land here, but it won't. If the mortar lands here, it's not going to spray shrapnel up into here. So people can still run out if they have to, but if they're in here, standing there with the drones, and the mortars are landing, again, the mortar, if it lands here, it's not going to be able to put shrapnel into there. And if it lands here, well, I mean, we may have to have a wall here, a HESCO wall here, but because if it landed here, it could send shrapnel in there. But the coolest thing about these HESCO walls is that there's just nothing to it. And this, the only purpose of this is to make a place for them to escape so that they could get out of there if they had to. So you could, you know, if you did that, then you just have to build it. If a mortar landed here, it would go in there. So you're gonna have to put another HESCO wall here. You have to make these right angle turns where sort of like this. And you might go, well, I don't know, that's a little tight for escaping. But the truth is, this from a scale viewpoint, this distance from here to here is 3.5 feet. So in exchange for, you know, being in a condition where a mortar can't get to you, you got to squeeze through an opening that's 3.5 feet wide and 9 feet tall. Who's going to complain about that? So there you go. And it's a lot of fun just to mess around with this. And you have your little tractor that's hooked up to the drone, and it just pushes the drones backwards into this facility. Oh, and the other thing I wanted to show you was, again, I just was surprised at how hard it is to get the size of a forward operating base. This is Forward Operating Base Delhi in Afghanistan, right there. And this is from Wikipedia. So there it is, Delhi. And again, Forward Operating Base Delhi. And finally, I was able to get a picture of the forward operating base and the size of it, because this has a scale in there, and you can click on this map. Oh, there, sorry. And there it is. So finally, we have a forward operating base, a real and actual forward operating base that we can look at, and we can say, okay, so we're going to build this hangar complex for our air operations, and this compared to that is what? And here is the Forward Operating Base Delhi next to the river here. This is an image in SketchUp. But this is, okay, here's 50 meters. So the, so if we measure this distance from here to here, that comes out as 50 meters. So this is all to scale. So you can see the point that I'm making here is that, you know, in terms of an effect on the base, that doesn't look to me like that much in exchange for the protection that that aviation community, aviation capability, aviation system is going to give to the people of this base. And I really think that the drones should be landing outside of the base in case something goes wrong. So they take off and land here. We'll have a helicopter or landing pad, and they get put into the safety area, and then they come out here like the hornets or the bumblebees that come out of the nest when there's trouble, and they go up in the air and help to save the soldiers. And the final image I wanted to show you. All right, so here they are showing the soldiers creating a bridge. United Kingdom. So these are, I'm just showing you the attribution so you can see it. But they have these same parts that have been the same type of parts that have been brought in for the little ATV bridge. It is exactly the same as this, except this is a lot bigger. But it does say to me, oh, and I had another image that's a little bit clearer of there. See, this is 5 feet. So the little ATV bridge, this distance was 3 or 4 feet. So this is quite a bridge here. But what it says is that the soldiers are completely capable of putting together a truss-based bridge. And you could actually turn this over and it could be the truss, a roof truss of a hangar, except this is pretty, I don't know, this is pretty heavy and it's probably expensive. And so I'm tempted to suggest to use this structure. And you can put a foot of sand on top of it and protect the plane. And one other thing I wanted to look at, I went to, this is the Red Horse Build a Combat Brigade base hammer. But you can see again how big it is, how much space there is around it. So there would be plenty of space to put in your air facility right here. And again, I don't, you know, the military has to pay for it and the men have to build it, but they get saved and they get a combat capability that they have not had before. So I think they would want to do it. And of course, it's always fun to finish up with Google Earth, because Google Earth is just fun. And we have a little crest tone here. I just don't understand why it exists. But there it is. The metropolis of Crestone. Google Earth is not intuitive to me how it works. But I was thinking, you know, if they were going to try, we could go to the Way of Nature Sacred Land Sanctuary. And you can see if we were going to have a base, a test base where the government would try out these drones, you could take this road here and build this base and build that hangar and fly the drones out, and you could fly them up to the Way of Nature Sacred Land Sanctuary and up the North Creststone Trailhead to practice flying around in your drone. As I said, the guy, Charlie, I think he thought that he was going to be spending his time flying around in the drone, and I think he's got to persuade the military to protect his drones. All right, and so this would be part 4, and we got some other things we got to do with the drones, but we'll wrap this one up at this point. And again, thank you everybody for being here. It's a lot of fun. I think it's time to understand that these drones need to be made available to the military to keep the soldiers from being injured.